Hi, I'm here to talk about lithophanes, the art of subtracting light to make an image, as you can see here. So what are lithophanes? Well, it's basically passing light through a semi-transparent material to create an image, as seen here. It can be done on CNC machines and also 3D printers, and many other ways. Can be made out of porcelain or whatever other wax, and in our case, plastic. So with this guide, you can skip around however you want. This video is meant to be long and meant to make sure that you don't get stuck anywhere, not necessarily the best edited. But anyways, what makes a good image? Think of an image that basically look good in black and white. So a high contrast image. As you can see, this image from the Lord of the Rings here, it is a high contrast image. It has a lot of rich dark blacks and very just almost white, just fire in it, which has created this nice contrast and creates this lovely lithophane. High detail is lost in the print because we're limited due to using FDM 3D printers. So high detail will blur together, especially as we're averaging together the pixel values. And then find a high resolution image. If you give the converter garbage in, you'll get garbage out. So for this example, I'm going to use this image here, which you just download it, save it to wherever you need it to be, and then you take your image and you drag it over to here, which this link is found on the next slide down here at lithophanemaker.com. Choose your image and upload it here. Then for frame options, pick no border print stand. This will ensure that you get the whole image and you don't have a border around it. Plus also it gives the support needed for 3D printing. For the lithophane resolution, set it between 0.2 and 0.1 pixels per millimeter. For the width and height, this is how you can crop your image, as you can see, and also gives you the height and the dimensions of your lithophane in millimeters. You can convert it from imperial to metric and fill whatever hole you need. For this example, I'm using a 100 millimeter width by a 50 millimeter height of our image down here, and this here will give you a view of what you're going to print. So for the max thickness, set it between probably 0.3 and 0.5 if you are not using a strong backlight. However, the more thickness you add to it, the less light will get through it in total, which means that you'll need a stronger backlight to actually see your image. However, it means that you have more detail as you have more just thickness to play around with the actual image and light. If you're using a strong backlight, I recommend you use 0.5 millimeters and then up the minimum thickness to 0.08. But if you're not using a strong backlight, aka if you're not using a fluorescent bulb or something that'll produce a lot of heat and might potentially melt your lithophane, then I'd go with a 0.4 minimum thickness, as this is usually the minimum diameter of the nozzle. The stand thickness, change this to 0.3 and change the stand angle to set to 80. And then from here you enter, it'll give you an estimated runtime and file size, and then you just enter in your email and download the STL. Grabbing the STL, you want to go to self-service and you want to find this program here. This is Dremel Dreamlab, if you see the name on the top there. And what you want to do is you want to take what you've just downloaded, open up the window, extract contents, and then you want to find the STL file, which is here. And you want to take it and you want to drag it into your window, into the program. Alright, as you can see, this thing is now in the program. We can see it, we can view it. The next thing you need to do is import the setting for this. In full disclosure, these settings are not optimal, however, they are good enough. So if you have a clue of what you're doing, please update these settings and, do your best to troubleshoot as is. But you can get these settings from right here, this Google Drive link. You go here. And this is on slide 6. You go here. Go to Dremel Lab. Download it. And then you take the downloaded file and you go up to your profiles, which is right over here. What you do is you go to manage profiles, go to import, and then select the profile. Then open it. After you import it, everything should be good. However, what you'll need to do is you'll need to switch over from whatever profile you are on right now to the profile that you just imported. Next, what you want to do is you want to look at what most of these settings are fine. Like I say, if you want to experiment with them, please tweak them and record your notes. Next thing you want to do is you want to go up to material and select your material. I am using Eco ABS as my material, so I'm going to select that. For this, here I just put keep. However, if you're printing Eco ABS, make sure that enabled print cooling is off, as ABS does not like cooling. However, if you're printing PLA or other materials, you may want to have print cooling on. Next, you want to check your temperatures. I'm using ABS. Its print temperature for this printer is 230 degrees. My build plate temperature is 60 degrees Celsius. However, if you're printing in PLA, you may need a different temperature. So seeing this and seeing how everything should be good, I'm gonna click prepare. And this will begin to slice the file. Slicing basically converts your image to G-code, and as you can see here, I've got a fair amount of there's a lot of detail in this, so it may not come out the best. But you can see the main faces. A lot of the times the spikiness of the image will be taken out by this, which is a good thing, as it enables you to, well, actually print these. You should not need any supports, as we are printing with a brim today, and brims usually, well, help support it very well. But anyways, I'm going to cut to preparing the printer in a second.